Alright, pre-calc, so 2.2 part 2 now. We're going to continue graphing quadratics. We're just going to do it in general form. And then we've actually already talked about max and min. This is when a is less than 0 and a minimum when a is greater than 0. But we're really going to need those again when we start talking about the applications of quadratic functions, which is what we will end today's lesson with. Okay, so the first part then, our general form, f of x equals ax squared plus bx plus c, which is typically how we see it. We still want to start by finding our vertex, so hk. Our vertex is always going to be a negative b over 2a, and our k value is always going to be plugging in that negative b over 2a. So you can think about it as f of negative b over 2a or f of h. Whatever we find h to be, we're just going to take it and plug it into that equation. And we're going to do x and y intercepts the same as we did in the last lesson, which means the x intercepts, you are saying that f of x equals 0. And you're going to want to do your quadratic formula there. And then our y-intercepts, we are doing f of 0, which in this case, in general form, it's nice and easy. The ax squared cancels out, the bx cancels out, and it's always just going to be f of 0 equals c. Okay, so jumping into an example right here, we have 2x squared minus 7x minus 4, which means we know it opens up because a is positive 2. And then if we're going to do negative b over 2a to find h, that's going to be a positive 7 over 4, which is going to give us 1.75. So our vertex is going to be at 1.75, and then we need to find f of 1.75. If I plug that in, I end up with negative 10.125. So that's our vertex. Next thing we want is our x-intercepts, which means, again, we are doing the quadratic formula there. If I do that, I end up with 2. If I say 2 times, whoops, that's not what I want. I want to do the quadratic formula. Okay, so I'm going to say that a is 2, b is negative 7, and c is negative 4. I plug that in. I get an x-intercept of 4, 0, and negative 0.50. Okay, then the last thing we're going to need is our y-intercept, which is f of 0, or always becomes c. So c in this case is negative 4, so we have a y-intercept of 0, negative 4. Okay, so I've got 5 points here. I'm sorry, we've got 4 points here. We're going to use one of them to find a fifth. I'm going to start with my vertex. So 1.75, negative 10.125 is going to be right about there. Okay, maybe even a little bit higher, pretty close to negative 10. So right about there. Then what I'm also going to do right now is draw my line of symmetry so that we can find a point that is symmetrical to the y-intercept in a second. So if I draw my line of symmetry, I know that then next I have x-intercepts at 4, 0 and y-intercepts at negative 0.50. I'm going to put those two on there. And then finally, this should be 0, negative 4. My y-intercept is 0, negative 4. I'm going to put a point right there. And I'm going to use this to find my point of symmetry. So it's 1.75 units to the left, which means I'm going to go 1.75 units to the right. And we should be at about 3.5, negative 4. And then to finish it off, I've got my 5 points. So I'm just going to draw a just wonderful parabola right here. And finish it off. Okay, hopefully yours looks better than mine. So next example then, same idea. We're going to find h, and be careful here because you see this is actually out of order. We're going to have negative x squared plus 2x plus 3. So a negative b over 2a is going to give us negative 2 over 2. So our vertex is going to be at positive 1, and then I'm going to plug that in. So if I say negative, or 1 squared negative is going to give us a negative 1, plus 2 times 1 is 2, plus 3 is going to give us a vertex of 1, 4. Okay, next thing we want is our x-intercept, so I'm going to plug into my quadratic formula. Remember, a is negative 1, b is 2, and c is 3, which is going to give me x-intercepts of negative 1, 0 and positive 3, 0. And then finally, my y-intercept, which is always just going to be 0, c, which is 3 in this case. And I'll even say since a is negative, we know we are going to open down. So I'm going to put a point at 1, 4. There's my vertex. Next, I'm going to put my x-intercepts, so at 3, 0, and negative 1, 0. And then I'm going to put my y-intercept, which is at 0, 3. And if I go back, I did it in different order last time, but if I throw in my axis of symmetry right here, now I can draw my point of symmetry. So our y-intercept is 1 to the left, I'm going to go 1 to the right. And finally, I'm just going to finish by drawing a nice, smooth curve. A little bit better than last time, that's for sure. So that would be it. Big thing, don't forget to find your points of symmetry here. Okay. So that is how we graph in general form. So we've done standard form, we've done general form. Now one big application of pre-calculus in general and quadratic formulas especially is when we start to talk about physics. So a lot of you who are taking physics right now have probably seen problems like this or have started to look at problems like this. Tomorrow we're going to start class with going over this problem. So I do expect you to have this problem attempted, parts A, B, C, and D. So I'll leave it down. We've got a person standing close to the edge of the top of a 200-foot building. So you need to remember that you are starting 200 feet up, throws a baseball vertically upwards, and it's going to give this function. Okay, now there's a few key numbers in here. We're not going to worry about that yet. We'll talk about it a little bit tomorrow, but it gives how high the ball is, s of t, in terms of time, t. And so you are going to need to use that function to find after how many seconds does the ball reach its maximum height. So think about what we're talking about if we are saying maximum, and what is that maximum height. And then how many seconds does it take until the ball finally hits the ground. And finally s of 0 describes what does that mean. And then you're going to graph it. So all of these things are important pieces that we've talked about this in lesson. We've talked about our vertex and our two types of intercepts. They all have to do something with this. And then you're going to use that to graph it. Okay, so that is it for Graphing Quadratics Part 2. We'll see you next time.